Hi everyone, welcome to our video on the derivatives of exponential functions. So for this rule, we have the derivative of the natural base exponential function, the derivative of e to the x, is e to the x. So it's its same old self. Whereas this portion is the chain rule with that e base. So the way I think of it is e to the power, the derivative of e to the power is e to the power, so it's copy and paste, times the derivative of the power. So e to the power times the derivative of the power is how I look at it with the chain rule. Okay, so let's break this down. So let's do a few problems here. So in our first problem, it's a multiple term scenario where we've got our f prime of x is equal to, well, this first one is just the power rule. So we would have 7's just hanging out, and then 12x to the 11. So that's our power rule. And then we have minus the 8's just hanging out. The derivative of e to the x is e to the x. It's going to be e to the x. That's it. There we go. And then we have plus x to the e. Now be careful, this is also just the power rule. So this is plus the power. So remember, e is a number. E is about 2.71. So e is a constant. E is a constant. Just like how we wrote this first part, we would do the same thing. So the e would come to the front. So this is e times x. And then minus 1 from the power, e minus 1. So when it's e, though, we usually just leave it as e, just like how we would with like pi. Pi, we leave the symbol as pi, but we still follow the same rule. So it's still take that power, multiply the front, and then minus 1. Okay, so that was still just the power rule. So I'm going to underline these were just power rules. Okay, so the ones that I underlined, those were just power rule. This portion with the blue underline, the double blue underline, that is our rule that we just found. So that's the derivative of the exponential function. And then this last portion, minus 2e, well, again, e's a constant. So this, because there's no x, so notice on this one that I underlined in blue, it was raised to the x power. This doesn't have a power on it, so this is just a constant. And so the derivative of a constant is 0. And I'm just putting a placeholder there for this problem. Okay, and then now we can simplify all of it. 7 times 12 is 84, and then x to the 11, minus this we could just say is 8e to the x, and then this we could say is plus ex to the e minus 1. Okay, so that's how they might use this first rule, where we used it on the blue portion. And it looks like they're trying to trick you in other spots. Okay, so if it's e to the x, the derivative of e to the x is just e to the x. Okay, in number 2, it is y equals x times e to the x. So remember, just saying it out loud can help with knowing that this is a product. So we do have a product. Let me write it over here so I can put parentheses. So this is a product that we currently have. So that means it's a product rule problem to set it up. So our product rule, our derivative of y with respect to x, is usually written as, I usually use u and v. So let's say this is going to be u, and this is going to be v. Then our setup is u, well, let me just keep it in black ink. Sorry, let's just do that. Is uv plus uv. And then remember, I go back and put the primes in. So u prime v plus uv prime. And then now I can start to plug those in. So my u prime, well, if my u is x, my u prime would be 1. And then my v is just e to the x. And then we have plus u, which is now, looking back at it, is still just x. And then our v prime, well, the rule for this is that it's e to the x. Okay, so that's that. And then now we can simplify this. This does become, let's put it over here. So it's 1 times e to the x is e to the x plus x e to the x. And then often with the product rule and e to the x, we would factor. Notice e to the x is common in both terms. So the way I'm going to write this is dy dx equals e to the x, I'm taking out, and then I'm left with 1 plus x. So in double check, remember if you FOIL or distribute, you can match with above. So this is correct. So usually I like to factor. Okay, anyway, so again, it's a real nice rule. And the reason that it works is if we were to do the limit definition. Okay, so just a very, very quick explanation. The limit definition, if we had our f prime of x would equal to the limit as h goes to 0 of, it would look something like this, e to the x plus h minus e to the x over h. Well, if we were to plug something in close to 0 here, this all eventually, for h, so if you plug something in close to 0 for h, it all simplifies into e to the x. So if you wanted to try this on a calculator, you could see it in our supplemental videos. It might go over that a little bit further. But the main thing, so we don't need to figure out why it does this. We just want to make sure we know that this is the rule. Okay, so anyway, so if you did want to check it out, feel free to. Okay, and then now let's try some of these problems. Well, for number 3, I've got, all right, so I have e to the 9w down below. Well, so I could use the quotient rule in this scenario, so that would be fine. Let's go ahead and let's do the quotient rule. So this is my high one, and this is my low one. Okay, so you could, I see it another way as well, and I'll make a note of that at the end, but let's go ahead and just use our quotient rule since it is something divided by something. Okay, so our quotient rule setup, g prime of w, would be low d high minus high d low all over low. And then I have, all right, so let's put the parentheses, there we go, and then the low one's still in red, like that. All right, so I'm going to plug this in. Let's put it in horizontal since I didn't give myself much room. Okay, so my low is e to the 9w. So I have e to the 9w, like that. And then times the derivative of the high. Well, the derivative of 2 would be 0. And then we have minus the high function, which is just 2. So we have minus 2. Times the derivative of the low function. Okay, so I'm going to do it in words. So remember the chain rule in words, when it's e to the power, I'm going to copy and paste e to the power. So it's e to the 9w times the derivative of the power. So times it by 9. And there we go. I think that's usually easier than just setting up your whole chain rule. I think saying it in words is easiest, and so that's why I'm doing it that way. Now, if that power were something crazy, maybe we would do some scratch work, but usually it's something that's not too bad. Okay, so so the derivative of e raised to a power with a variable in it, e to the power is e to the power times the derivative of the power. Okay, and then over the low one, which on this problem, low one times the low one, I am gonna write it like this for this scenario. Okay, and then now that we have it written like this, let's continue to simplify. So my g prime of w is, okay, so notice I have, this would be just 0 in my numerator there. And then minus would be negative. So negative 2 times 9 is 18. So I wanted to combine those. So the 2 and the 9 is 18. And then e to the 9w is still just attached. And then down below, I have e to the 9w times e to the 9w. So that's why I left it separate in this case, because I can say, hey, e to the 9w would just cancel with e to the 9w. And so then we've got our final answer is g prime of w is negative 18 over just e to the 9w. There we go. Okay, so that is our derivative. Now, the other way we could have done this problem, we could have used our rules for powers before we did any derivative. So I'm just going to kind of block that off in the purple. So g of w would have been the same as 2e to the negative 9w, like that. Okay, so that's using the rules for negative powers. Remember, if you have something in the denominator, you could put it up as long as you make the power on it negative. Okay, and then now if I were to do this derivative, g prime of w, this 2 is just hanging out. And then the derivative of e to the negative 9w is, copy and paste that, e to the negative 9w times the derivative of the power. Well, the derivative of negative 9w would be negative 9. And then notice that 2 would times negative 9 to give us negative 18. And then e to the negative 9w is the same as e to the 9w down below like that. So they are the same. So notice the quotient rule was the harder way to do this problem. So just because you see something set up as the quotient rule doesn't mean instantly to jump into it if you don't want to. So, I mean, it worked out. But notice sometimes it's easier to manipulate first. Okay, so let's do one other. So our s of t equals 4e to the 3t squared plus 5t minus 1. All right, so in this problem, again, I'm gonna do it in words. S prime of t is equal to, well, the 4 is just hanging out. And then the derivative of your e expression, e to the power, is the e to the power. So I'm going to copy that exactly. So e to the 3t squared plus 5t minus 1. And then I just think also times it by the derivative of the power. So 6t, so I can see it's just power rule. So 6t plus 5. And then that's it. We're done. Okay, so you can box that up one step. So it kind of doesn't matter if it gets crazy in that power. It's usually still just kind of one step, especially if we do it in words. Okay, so that's that. So that is our rule. So the e to the x derivative is itself. E to something that's a little weirder, well, e to a power has the derivative of e to the power times the derivative of the power. Okay, so that's it. So e to the power, and so again, this is e to the power times derivative of power is all I'm doing to get these answers. Okay, so that's that. All right, so we'll take a look at a different scenario in our next video, but for now, that's it. So thanks for watching, and please let me know if you have any other questions.